In this video, I am going to give the solution of question number 1 to 6 of exercise 10.4, which is from class 12 maths vector chapters. And I am starting with the first question. It is given two vectors A and B, and you are asked to find their cross product and the magnitude of cross product. So first we will find the cross product. A and B. Cross product is found by determinant, which we have discussed earlier. It is found by determinant in which the first row is made by ijk and the second row is made by the coefficient of first vectors, coefficient 1, minus 7 and 7. The third row is made by the coefficient of second vectors, that is 3, minus 2 and 2. And this is a third order determinant. We will expand it using the first row. Expanding using first row is ijk. So it is like this, the pattern is like this, plus I minus j plus k, and when I, the coefficient of I is a second order determinant which is made like this, you close I with both j and both row and column, and the remaining is making this determinant. Remaining is minus 7, 7, minus 2, 2, and same pattern for j and k also. For j we have to close j and with both row and column, and the remaining, that is 1, 7, 3, 2. And for k, if we close k with row and column, remaining is. So these are the second order determinants which we find like this: cross multiply this direction minus in this direction. That means I into, it will be this direction 7 into 2 minus in this direction minus 2 into 7. Same pattern for both j and k. 1 into 2 minus 3 into 7, plus for k also 1 into minus 2 minus 3 into minus 7. And if we simplify, it is 0i plus 19j plus 19k. This is what we have got, is the cross product A cross B, cross product of vectors A and B. In the second part, we are asked to find the magnitude of the cross product. The second step, we are to find the magnitude of this vector. This is the A cross B and its magnitude. Magnitude is found like this. It is under square root sum of square of coefficients. Coefficient of I is 0 square, coefficient of j is 19 square, coefficient of k also 19 square. We can simplify and get the result. 19 square is twice, and for 19 now square and root will get cancelled, so 19 will be out. It will be 19 and 2 will remain in the root. And this is the solution for this question. Question number 2, you are asked to find a unit vector perpendicular to a plus b and a minus b, where a and b are given. So before solving this question, we must have idea about this certain terms. I have explained the first one. Unit vector along a. Unit vector along a vector a is given by vector divided by its magnitude. Then a vector perpendicular to a and b is given by is the cross product of two vectors. Whenever you say you are asked to find a vector perpendicular is given by cross product. Unit vector is a vector divided by its magnitude. Now if we combine these two together, unit vector also, perpendicular also. See, unit vector and perpendicular, both 1 and 2 combined. That means perpendicular vector is given by cross product, and unit vector is given by dividing magnitude. A unit vector is formed by dividing by the magnitude of the vector, so we have to divide by the magnitude of a cross b. So this is the formula to find a unit vector perpendicular to both a and b. Now the same term again changing, unit vector perpendicular to not a and b. A is replaced by a plus b, b is replaced by a minus b. So this same formula, in place of a we will have a plus b, in place of b we will have a minus b. So this will be given by a plus b cross a minus b vectors divided by the magnitude of the vector, magnitude of a plus b cross a minus b. So this will give the vector which is perpendicular to both a plus b and a minus b is given by this formula. And this question, it is exactly matching with this condition. We are asked to find a unit vector perpendicular to a plus b and a minus b. So we have to find this. So the first is to find So at first given vectors a and b, and we have to find a plus b. So a plus b, we are adding the 2. So if we add, it will become 3 plus 1 is 4i plus 4j plus 0k. Then a minus b again. If we subtract 3 minus 1 is, it will be 2i 0j, and 2 minus plus, it will become 4k. So we got a plus b and a minus b vectors, and then we have to find out the cross product between these two vectors. These two vectors cross product, which we know it is found by using determinant. First row is made by ijk. The second row is coefficient of first vectors. First vector is here 4 4 0. Second vector coefficient is 2 0 4, and we'll expand using the first row. I minus j plus k. These are second order determinants. When I, we have to close I with row and column. Just now we have done in the previous question. The remaining is forming the determinant. For j, it will be same pattern like this. For k also same pattern. It will be 4 4 2 0, and then we will cross multiply this direction minus this direction. So it will be 4 4 is 16 I into 16 minus 0 j into 16 minus 0 plus k into 0 minus 8. So finally it is 16i minus 16j minus 8k, and then we have to find its magnitude. Magnitude, we know this is the vector a plus b, a minus b cross product. It is the vector, and we are asked to find it. Now we have to find its magnitude, because this is the term as we have just now discussed. We are finally to find this term. So magnitude is first coefficient of I square, coefficient of j square, coefficient of k square, and it is 256 plus 256 plus 64. It is square root of 576, which is the square of 24. So 24 square, that means square and root cancel, it is 24. And then this is the vector, required vector, a unit vector perpendicular to a plus b and a minus b. So it is, this is the vector 16i minus 16j minus 8k divided by 24, and we can simplify more. We can take 8 common, 2i minus 2j minus k divided by 24, and 8 3s are 24. So 2i minus 2j minus k divided by 3. This is the result for this question. A unit vector, then if a unit vector, then this is the term, and if the question is mentioned unit vectors, if it is mentioned vectors, vectors means plural, more, in that case you will take plus minus sign. But when it is said only a vector, then plus minus is not necessary, only positive, plus not minus, minus is not necessary. So this is the solution for this question. Plus minus is not there because in the question you are asked to find a unit vector, so we will take only the positive one. Question number 3. A unit vector A makes angle pi by 3 with I pi by 4. It is like this. A unit vector, we know this angle alpha, it is pi by 3, it is given. With j, we represent by beta, it is given pi by 4. And with k angle gamma, we represent by, which is not given theta, we have to find it. And the formula we are going to use it, cos square alpha plus cos square beta plus cos square gamma is equal to 1. Actually it is cos alpha, cos beta, cos gamma are also represented by L, M, N, and these are also called direction cosines, and sum of squares is always 1. Now here alpha is pi by 3, square is there, beta is pi by 4, square is there, and cos square gamma is theta, which we are going to find. Cos pi by 3, cos 60 is 1 by 2 square, cos pi by 4 is 1 by square root 2 square, cos square theta is equal to 1. I will simplify. 1 by 4 plus 1 by 2 plus cos square theta is equal to 1. And then if we take LCM 4, 1 plus 2, then 3 by 4. And we will find out cos theta, cos square theta is equal to, cos square theta is 1 minus 3 by 4 is equal to 1 by 4. Then what will be cos theta? Cos theta is equal to plus minus square root of 1 by 4. So cos theta is equal to plus minus 1 by 2. But it is mentioned in the question, theta is an acute angle. Acute angle means positive. It is less than 90 degree. So cos is positive. So we have to take cos theta is equal to 1 by 2. And 1 by 2 is the value of cos 60 pi by 3. Cos cancel, so theta is equal to pi by 3. So the first part of the solution we got. First part is to find theta. We got the value of theta. Theta is pi by 3. The second part is component of A. What are the components of A are now? Components of vector, unit vector A are cos alpha, comma, cos beta and cos gamma. These are the direction cosines. Direction cosines are the coefficients of the unit vector. Coefficient of unit vector, remember, coefficient of unit vector are the direction cosines. That means cos alpha, cos beta and cos gamma. So cos alpha we have here 1 by 2. Cos alpha is 1 by 2. Cos beta is 1 by root 2. And cos gamma, that means cos theta is also 1 by 2. So these are the components of the unit vector A, and this is the complete solution. First part is to find the angle. We got the angle here. The second part is components of the unit vector, which are the direction cosines, that is cos alpha, cos beta and cos gamma. Question number 4. We are asked to prove that A minus B cross A plus B equal to twice A cross B, for which we have to know that A cross B is minus of B cross A. Cross product, if we interchange, there will be negative sign. So this is the first point we have to know. The second point we have to know is A cross A is equal to 0 vector, which we have discussed in the first lecture. Now we'll take the LHS. LHS is A minus B cross A plus B. We will just multiply, same like algebraic multiplication, but in between there is cross. A with A cross B minus, no, plus into plus is plus, A cross B, then B A negative, B cross A and B cross B. So we have just multiplied same like algebraic multiplication, but in between there is cross. So in every term in between the vectors there is cross. And then we have discussed here A cross A is 0 vector, A cross B will remain same. B cross A, if we interchange, it will be minus of A cross B. We have discussed here in cross product, if we interchange, there will be a minus sign. And then B cross B is 0. By this second formula, B cross B is a 0 vector. Then what is remaining? A cross B, minus of minus is plus, again A cross B. That means A cross B is twice of A cross B. And this is the right hand side. It is the complete solution. We have to know only these two formula in solving this question. Question number 5. It is given cross product of two vectors is 0 and there are certain terms unknown, lambda and mu. Lambda and mu unknown, we are asked to find lambda and mu. So I'll write like this. First step given, this is the given equation, and then cross product. Cross product is found by using determinant, which we know. Cross product, first row is made by ijk. Why finding cross product? Because in between there is cross product. First row is made by ijk, then second row is made by the coefficient of first vectors 2, 6, 27. Then third row is made by coefficient of second vector 1, lambda and mu. And this is a second order determinant, third order determinant. We know how to expand. We will expand by using the first row. Plus, minus, plus. When I coefficient we are finding, then we have to close I with row and column, and the remaining makes this determinant. This is a second order determinant. Same pattern followed for J, close and the remaining 2, 27, 1, mu. And again same for K also, 2, 6, 1, lambda. Right hand side is 0 vector. And all this second order determinant we know how to find. Cross multiply this direction like this direction 6 mu minus 27 lambda minus J into this direction twice mu minus in this direction 27 plus K into this direction twice lambda minus 6 is equal to, right hand side 0 is not algebraic 0, it is 0 vector. It is a vector whose coefficients are 0 0 0. That means 0i, 0j and 0k. Now we'll equate the coefficient on both sides. Coefficient of I must be equal to coefficient of I. So we'll write equating coefficients of I, j, k on both sides. Coefficient of I must be equal to coefficient of I is 0. The same way coefficient of j, it is negative. Negative of twice mu minus 27 also must be equal to 0. Coefficient of k must also be equal to 0. Now we can solve this. First 2 lambda equal to 6, lambda equal to 6 by 2, so lambda is equal to 3. We got the value of lambda at first from here. Now from here we can get the value of mu. Minus 2 mu, minus of minus is plus 27 equal to 0. Minus twice mu is equal to minus 27, minus is getting cancelled, mu is equal to 27 by 2, and you got the value of lambda and mu. You can put the values and you can see here it is satisfied by third condition or not. Obviously it is going to satisfy. So this is the complete solution. Next question number 6, it is given like this: a dot b equal to 0, a cross b also 0. A dot b is 0, it is algebraic 0, and a cross b is 0, vector 0, because cross product is a vector. Now the question is, what can you conclude about the vectors a and b? Dot product 0, cross product also 0, then what can you conclude about the vectors a and b? Dot product definition is magnitude a, magnitude b, cos theta equal to 0. Cross product definition is magnitude a, magnitude b, sin theta into n cap is equal to 0 vector. Now since right side is 0, then these three factors, either a must be 0, or this must be 0, or this must be 0. Now if we take cos theta is 0, that means vectors a and b must be perpendicular. Cos theta 0 means theta is 90 degree, vectors must be perpendicular. If we take the first third factor 0, then vectors perpendicular. Here if we take sin theta 0, then sin theta 0, then the vectors must be parallel. A and b are parallel. So at the same time two vectors perpendicular as well as parallel not possible. So we cannot take cos theta 0, we cannot take sin theta 0. N cap is a unit vector which we cannot take 0. It is a unit vector by definition. So we must have this factor 0, this 2 0. That means either a 0 or b 0. So the conclusion is either magnitude of a must be 0 or magnitude of b must be 0. So this is the conclusion for this. Either magnitude a must be 0 or magnitude b must be 0, because cos theta 0 and sin theta 0 together not possible, because if cos theta 0 vectors perpendicular, sin theta 0 vectors parallel, and two vectors at the same time perpendicular parallel not possible, and hence we have to see this factor, this part, two factors exactly same in both. So either a magnitude must be 0 or b magnitude must be 0. So this is the complete solution. This is the end of this video, in which I have given question number 1 to 6 of exercise 10.4, and that remaining questions I'll give in the next video. Question number 7 to the end of the exercise we'll give in the next video.